Okay, so the last question, about time, on May 2009, uh, is a binomial question. You tell that from. Oh God, pens against me today. Um, Binomially distributed with n50 and p 0.15. So it wants us to find for part AI the probability that r is less than 10. I want you to be very, very careful with less than 10. 0, 1, 2, 3, uh, 9, 10, 11, all the way up. Less than 10. Does less than 10 include 10? Well, the answer is no. Otherwise, I would have said less than or equal to 10. So, with it being less than 10, it just wants from 9 down. So I look up in my tables the probability that r is less than or equal to 9. And if I do that, I get, oh, here we go, where are they? There you go, 0.791. All right, so for part II, 0.01, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all up to 50. What it wants is the probability that r is between 10 and 5, and this time it includes 10 and 5 because it's less than or equal to and greater than or equal to. So I actually want that there. That's what I want. Now I would get that by doing the probability that it's less than or equal to 10, that one there, minus the probability, now you've got to be careful here, less than or equal to 4. A lot of people, because they see 10 and 5 here, do the probability that it's less than or equal to 10 minus the probability it's less than or equal to 5. But if you've done that, you've taken away the 5. You've taken away the fact that 5 was included. So you must take away 4, less than or equal to 4. So you do the probability that r is less than or equal to 10 minus the probability that r is less than or equal to 4. Big mistake there. People always take away 5. I look those numbers at my tables. 0.8801, take away 0.1121, and I get the answer at 0.768. Okay, so 4 marks. Thank gosh, that wasn't too bad. I think the technique really is to be very careful with the less than or equal to's, but I really do think that drawing these lines out helps me immensely. I used to make a lot of mistakes, but since I started drawing the lines out, it really makes it clearer in my head. Dave Evans taught me that little tip, and I've used it ever since. I think it's a great little bit of work, and it helps you a lot. So for part B, it's assumed that Miss Viewer sorts letters incorrectly. The probability that happens is 0.06, and her sorting a letter is independent from letter to letter. So calculate the probability that when sorting a batch of 22 letters, that's n is 22, she sorts exactly 2 incorrectly. So you can't find a table for exactly for 22, and for exactly we normally do something a bit different. We normally use a different technique. So we would do 22 choose 2 multiplied by the probability of getting one incorrect, 0.06 to the power of 2 times 0.94 to the power of 20. That's exactly 2. This bit here is your 2 incorrect and then 20 correct, and then this NCR, this 22 choose 2 is because it doesn't have, it could be in any order, so that you could have 20 correct and then the last 2 incorrect, or you could have the 10th one being incorrect and the 15th one. So there's a lot of different combinations, and there's 22 choose 2 combinations of finding 2 out of the 22 being incorrect. So this is the probability of getting one of just one of the combinations, so of getting 0.06 twice, the probability of getting 2 incorrect and then 20 correct. If you type that into your tables, into your calculator, it's been a long day, I do apologise. The pen's going all over the place. I get 0.24. There you go, 0.24. So for the next part, calculate the probability of sorting a batch of 35 letters, so n has changed. She sorts at least one letter incorrectly. Now you're not going to go through going exactly 1, exactly 2, exactly 3, exactly 4, all the way up to exactly 35, and then adding them together. We've got to find a quicker way. So if she sorts at least 1 incorrectly, that would be 1 minus the probability she sorts none incorrectly. Now that I can work out really quickly. So it's 1 minus, and don't forget to do 1 minus this, the probability she sorts at least, sorts exactly none incorrectly. So that would be 35n now. Choose 0, 0.06 to the power of 0, 0.94 to the power of 35. And if I do that on my calculator, again, don't forget to take it away from 1, you get 0.885. So I'll calculate the mean and the variance. Well, binomial I know 2 formula, NP, and then for the variance, NP 1 minus P, or NPQ. Okay, now why would they have gone to the trouble of making this word correctly bold on the exam paper? They've done it for a reason, so you've got to think why would they go to the trouble of making that correctly bold? Well, the reason for it is because n is 120. That's easy. But a lot of people would use p as this 0.06, which it has been for part I and II. But actually, that 0.06 is a probability of sorting one incorrectly. And this question is now correctly, so I actually need to do 1 minus 0.06. So for the mean, it would be 120 times 0.94. And for the variance, I'd have to do 120 times 0.94 times 0.06. And that would give me 6.768, and this one would give me 112.8. Now, the last part then, so Miss Fewer sorts a random sample of 20 batches, each containing 120 letters. The number of letters has a mean of 112.8 and a variance of 56.86. Comment on the assumption that the probability that she sorts a letter incorrectly is 0.06, and that is sorting of a letter is incorrectly is independent from letter to letter. So the means are the same. If you notice, the means are exactly the same. So I think that the probability of sorting a letter correctly is 0.6 is probably an accurate assumption. But the variance is very different. It's gone from being 6.768 to 56.86. So I don't think you could say that sorting of a letter incorrectly was independent from letter to letter. So for the 3 marks, I think you need to compare the 2 means and say that they're the same. Compare the 2 standard deviation, the 2 variances, and say that the variance was a lot higher, and therefore for the last 2 marks, say that you can assume that the probability is probably 0.06, but that you don't think it's independent from letter to letter.